March, North Slope, Alaska. Workers step off a cargo plane into -50°C air and won't see home again for 3 weeks. They'll sleep in modular rooms stacked like shipping containers, work 12-hour shifts drilling through permafrost, and spend every off hour inside buildings connected by heated corridors, because stepping outside, unprotected, means frostbite in minutes. The isolation is absolute, the work is relentless, and the single most critical piece of infrastructure keeping this operation running isn't the drilling rig or the heated modules, it's the kitchen. These workers need 4,500 calories every day. Their bodies burn fuel at twice the normal rate just staying warm. But here's the problem: extreme cold kills appetite. The very environment demanding massive energy intake actively suppresses the hunger signals that would drive them to eat. So how do you feed someone who needs twice the fuel but doesn't feel hungry? How do you deliver fresh food to a camp surrounded by nothing but ice when the entire state of Alaska keeps less than a week of reserves? And what happens when supply lines fail and the emergency clock starts ticking down to 30 days? This is the story of what Alaska's Arctic oil workers actually eat while living in total isolation. We're looking at the 24-hour kitchen operations feeding crews around the clock, the dual supply chains flying in king crab while engineering million-gallon ice roads, the emergency reserves designed as much for psychology as survival, and the neuroscience behind why comfort food isn't a luxury in these camps. It's a calculated safety investment. In the Arctic, the warm meal is life support. Arctic workers face a physiological equation that doesn't balance. The baseline is simple. A day of heavy manual labor burns 3,000 to 4,000 kilocalories. Pulling drill pipe, tripping in oil field terminology, means hours of sustained physical exertion, hauling heavy equipment in and out of the borehole. That alone would push caloric requirements above normal, but on the North Slope, the baseline is just the starting point. Thermoregulation is the primary energy tax. At -50°C, the human body becomes a furnace running at maximum output just to maintain core temperature. Every breath costs energy to warm frozen air. Every exposed surface radiates heat into an environment engineered by physics to extract it. The body compensates by burning through fuel reserves at an accelerated rate, converting calories into the metabolic heat needed for survival. Then there's the gear. Workers don't move freely in the Arctic. Bulky insulated suits, heavy boots, protective equipment. Every task requires fighting against layers of safety clothing that add weight and resistance. Walking across camp becomes an effort. Climbing onto equipment means hauling extra mass. The physical tax of simply moving through the environment compounds the energy cost of the work itself. The U.S. military sets its recommended dietary allowance for males operating in environments colder than 14°C at 4,500 kilocalories per day. Research on cold climate performance confirms this range for individuals engaged in continuous high-level physical activity. The number isn't a suggestion, it's the threshold where human function remains stable. Drop below it consistently, and the deficit starts showing up in performance metrics. Energy deficit doesn't just mean weight loss. The body compensates by degrading both physiological and cognitive function. Reaction time slow. Decision-making deteriorates. Fine motor control suffers. In an environment where equipment failure can mean immediate death, where a single miscalculation during drilling can trigger catastrophic system collapse, impaired performance isn't acceptable. It's the primary threat. Human error kills in zero-tolerance operations, and underfed workers make errors. But here's where the system breaks down. Extreme cold suppresses appetite. The appetite paradox is well documented in cold environment research. Workers exposed to severe cold and high stress consistently underestimate their energy needs. A body burning 4,500 calories doesn't necessarily signal hunger for 4,500 calories. The internal regulatory system that should drive eating fails to match the actual energy expenditure. Workers feel full when they're operating at a dangerous deficit. The camp food system exists to override this failure. Meals are engineered for hyperpalatability, high in fats, sugars, and salts that trigger consumption past natural appetite signals. The body might lie about hunger, but the brain responds to sensory reward. Rich, flavorful food forces intake when willpower alone would fail. The kitchen isn't trying to provide balanced nutrition in the abstract sense. It's trying to push 4,500 calories into workers whose biology actively resists the necessary fuel load. The work rotation defines everything. 3 weeks on, 3 weeks off. During the on-cycle, workers adhere to 12-hour shifts that structure every waking moment. The meal schedule exists to anchor this operational tempo. Breakfast happens fast. The 6:30 a.m. safety meeting is non-negotiable, which means workers eat before the briefing, often in a rush. The menu reflects the time pressure: eggs, bacon, sausage, hash browns, dense, traditional high-calorie foods that can be consumed quickly. This is the lumberjack breakfast, designed not for enjoyment, but for rapid fueling before the shift begins. Workers need a massive caloric front load to carry them through the morning's physical demands. The day shift runs until early evening. Crews return to camp around 7:15 p.m. after the equipment is secured and the debrief is complete. They shower off the day's work, then head to the dining hall. Dinner is the recovery meal, the most important eating event of the rotation. After 12 hours of exertion in extreme cold, the body is depleted. This meal exists to replenish energy stores, provide the nutrients needed for overnight recovery, and prepare workers for the next day's identical cycle. But this traditional structure only works for day shift. Drilling doesn't stop at night. Oil extraction is a continuous industrial process running 24 hours without interruption. Night shift workers face an immediate problem. Their bodies expect to eat at certain times, but their work schedule inverts the normal daily rhythm. Dinner at 3 a.m. isn't just inconvenient, it's physiologically disruptive. Circadian biology governs appetite signals. The body anticipates meals based on learned patterns and light exposure. When those patterns are disrupted, when workers are awake all night under artificial lighting, when their dinner happens in the middle of what their internal clock recognizes as deep sleep hours, the disconnect creates stress. Appetite suppression intensifies. The already difficult task of consuming 4,500 calories becomes even harder when the meal schedule fights against millions of years of evolved timing mechanisms. The midnight meal problem isn't theoretical. Night shift crews need the same caloric intake as day shift, but their window for eating is compressed and biochemically hostile. A worker finishing a shift at 3 a.m. needs a full recovery meal, but their body is primed for sleep, not digestion. They need breakfast before starting at 6 p.m., but eating a heavy meal at what feels like late afternoon violates every natural eating instinct. The traditional 3-meal structure breaks completely under continuous operations. The answer is temporal decoupling. If workers can't reliably align their eating with traditional meal times, the system removes meal times entirely. The Spike Room is a 24/7 self-serve facility providing continuous access to hot food. It's not a break room with vending machines. It's a full-service buffet that never closes, stocked with prepared meals, hot entrees, sides, and drinks available at any hour. A worker returning from a midnight maintenance task can walk in at 2 a.m. and find fresh, hot food ready to eat. A day shift worker waking early can access breakfast hours before the dining hall opens for the morning rush. This infrastructure solves the circadian mismatch. Instead of forcing night shift workers to eat full meals at biologically inappropriate times, the Spike Room lets them graze throughout their waking hours. A worker can eat a smaller portion when their body actually signals hunger, then return later for more. The total caloric intake remains on target, but the delivery method adapts to the individual's disrupted schedule rather than imposing rigid eating windows. Hot meal. Set aside complements the continuous access. Night crews can request that a specific meal be prepared and held for them, guaranteeing fresh food rather than leftovers. A worker knows that when they finish their shift at 3 a.m., a hot dinner, freshly plated, not reheated, will be waiting. The kitchen staff maintains a production schedule that accounts for these off-cycle requests, treating night shift meals with the same priority as the main dining hall service. The operational effect is synchronization with work tempo rather than clock time. Drilling operations don't pause for meals. Equipment doesn't care what hour it is. By decoupling food access from fixed schedules, the camp aligns sustenance delivery with actual operational needs. Workers eat when their bodies can process food, when their work allows breaks, when the appetite suppression temporarily lifts. The system prioritizes getting 4,500 calories into each worker over maintaining traditional dining customs that simply don't function in continuous industrial operations. The kitchen itself runs as an industrial operation. Specialized contractors operate these facilities, requiring staff with commercial kitchen experience and regulatory certifications. Alaska Food Worker Cards serve safe credentials. The chefs aren't just cooks. They're food logistics managers responsible for menu development, recipe selection, and maintaining quality standards across hundreds of meals per day. The scale demands precision and professional expertise at every level. Alaska's food security exists on a knife edge. 95% of the state's food is imported. Nearly all of it arrives through a single pathway. Ships from the Port of Tacoma to the Port of Alaska in Anchorage. From there, ground transport distributes supplies across the state. This centralized system creates efficiency, but it also creates vulnerability. The entire state maintains only 6 to 10 days of food reserves. That's the total buffer between normal operations and crisis. A disruption at the Port of Tacoma, labor action, weather closure, infrastructure failure would immediately trigger supply shortages across Alaska. A problem with the Port of Alaska's receiving infrastructure would have the same effect. The Alcan Highway, the primary ground route connecting Alaska to the continental U.S., is a single roadway through Canadian wilderness. Close it for a week, and the state starts rationing. For urban populations in Anchorage or Fairbanks, this fragility is partially offset by proximity to distribution networks and the ability to redirect supplies through alternative routes if needed. For rural communities, traditional subsistence practices provide backup: hunting, fishing, and gathering supplement purchased food, offering a buffer when store shelves empty. Oil camps have neither advantage. They're too remote for emergency ground resupply from urban centers. They can't supplement through subsistence because the industrial workforce isn't trained for Arctic hunting, and the scale of consumption, feeding hundreds of workers, far exceeds what local hunting could sustainably provide. The camps operate in complete dependence on industrial supply lines with no local alternatives. This means North Slope operations must build fortress-level self-reliance into every logistics protocol. They can't assume resupply will arrive on schedule. They can't rely on the state's distribution network. If the broader Alaskan food system enters crisis, the camps are on their own. The entire operational model shifts from just-in-time delivery to deep buffer stockpiling, treating food security as a tactical asset rather than a routine expense. The solution to fragility is redundancy. North Slope camps maintain two completely separate supply chains, each serving distinct purposes and operating on different timescales. Air freight handles perishables and morale-critical ingredients. Daily cargo flights run through Dead Horse Aviation Center, providing near-continuous pickup and drop-off service. Fresh fruits and vegetables, high-quality cuts of meat, seafood. Anything with a short shelf life or high psychological value flies in by air. The cost is enormous. Air cargo rates to remote Arctic locations are multiples of standard freight, and the daily flight schedule means paying those premiums constantly. But the expense buys reliability. Aircraft can operate in weather conditions that ground trucks. They're not dependent on seasonal road access. When a menu calls for ribeye steaks or fresh salmon, air freight guarantees delivery within 24 hours of order. The consistency matters as much as the speed. Workers rotating into camp for their 3-week shift expect certain standards. If the kitchen can't deliver fresh ingredients reliably, retention suffers. The menu reflects this investment. King crab baked penny, smoked salmon frittatas, grilled sockeye salmon, Alaskan king crab. These aren't survival rations. They're restaurant-quality dishes delivered to one of the most remote industrial sites on Earth. The continuous presence of fresh, high-end food is recognized as essential for maintaining worker retention and daily psychological well-being in an environment that offers no other comforts. Ice roads handle the bulk. Every winter, engineers construct temporary highways across frozen tundra and sea ice, connecting North Slope fields to the Trans-Alaska Pipeline Haul road system. These roads, sometimes called the Hickle Highway historically, are engineered structures requiring massive logistical effort. A single mile of ice road demands approximately 1 million gallons of fresh water to construct and maintain. The operational window is narrow. Ice roads exist only in deep winter when temperatures stay low enough to maintain structural integrity. Once spring thaw begins, the roads vanish. This seasonal constraint means the entire year's heavy resupply, construction materials, fuel, long-term food staples, must move during a compressed time frame. Missing the window means waiting another year. The dual system investment confirms food security as a core operational cost. Maintaining daily air freight plus seasonal ice road construction requires enormous capital expenditure, but the alternative, supply chain failure in a zero-tolerance environment, is unacceptable. The redundancy isn't wasteful, it's essential infrastructure for maintaining consistent output in the high-demand Arctic theater. When storms ground planes and ice roads close, the countdown begins. North Slope camps maintain minimum 30-day emergency food reserves specifically for these scenarios. The composition is strategic. Commercially canned goods form the core: meats, fish, beans, fruits, vegetables. These items are already cooked, shelf-stable, and can be consumed directly from the can without water or special preparation. They require no power for storage and no cooking infrastructure to use. In a crisis scenario where utilities fail, canned goods remain accessible. Long-term dry staples supplement the canned inventory. Rice, oats, pasta, dry mixes, powdered milk, peanut butter, dried soups, all stored in airtight food-grade containers kept off the floor in clean, dark spaces to prevent moisture damage and temperature fluctuation. These items extend the reserve timeline and provide variety beyond canned rations. Ready-to-eat items round out the cache. Meals, ready-to-eat jerky, trail mixes, granola bars. Foods requiring zero preparation and offering immediate caloric density. These serve as the last line when all other systems fail. The storage protocol is meticulous. Reserves are integrated into regular stock management, with older items rotated out through normal consumption before expiration. This prevents costly loss and guarantees freshness. The inventory is treated as living stock, not forgotten emergency cash. Contingency protocols dictate usage order during power loss. Refrigerated perishables get consumed first, before they spoil. Freezer contents come next. They can be held cold for a time with proper insulation, but eventually thaw. Only after exhausting those resources do crews resort to shelf-stable reserves. This staged approach maximizes resource utilization and delays rationing as long as possible. But the reserves aren't designed purely for caloric sufficiency. Contingency planners incorporate a psychological buffer into the 30-day cache. The composition includes familiar comfort foods specifically because, as experts note, these items lift morale and give a feeling of security in time of stress. The logic is tactical. Rationing is physiologically possible. Healthy adults can survive on reduced intake for extended periods, but the psychological impact of protracted crisis poses greater operational risk. Panic destabilizes crews. Fear spreads faster than hunger. Workers make worse decisions when they're psychologically compromised, and in high-risk industrial environments, bad decisions kill. Familiar foods combat this threat. A worker eating recognizable meals maintains emotional stability even as external conditions deteriorate. The reserve isn't just fuel, it's psychological armor against the mental breakdown that threatens operational integrity more than caloric deficit. Traditional cold storage systems are failing across the region. Inupiat communities have used subterranean ice cellars for generations, but permafrost thaw is destroying this infrastructure. Cellars warm, food spoils, structural integrity collapses. Industrial camps avoid this vulnerability through engineered refrigeration systems housed in modular structures built on pilings that prevent heat transfer to the permafrost below. The technology insulates the camps from the environmental degradation affecting traditional systems. The daily menu at a North Slope camp reads like a high-end restaurant: king crab baked penne, smoked salmon frittatas, wild blueberry cobbler, ribeye steaks on designated steak nights. These aren't occasional treats. They're standard offerings in the continuous meal rotation. The investment seems excessive until you understand the retention calculus. North Slope work demands extreme compensation. The isolation is complete. Workers spend 3 weeks away from family, confined to modular buildings surrounded by hostile environment. The work is dangerous. The conditions are brutal. The sacrifice is immense. High salaries attract workers initially, but money alone doesn't guarantee they'll return for another rotation. Living conditions must offset the psychological cost of isolation. Workers need to feel the sacrifice is recognized, that the compensation extends beyond their paycheck into daily quality of life. Food becomes the most tangible demonstration of this recognition. The neuroscience supports the strategy. Comfort foods trigger specific brain mechanisms that provide measurable psychological benefits. The hippocampus stores associative memories linked to specific foods. The amygdala tags those memories with emotional valence. When workers eat familiar, pleasurable foods, these systems activate, creating mental safe spaces that evoke nostalgia and positive emotional states. In isolation, comfort foods function as social surrogates. Their consumption triggers oxytocin release, the hormone associated with social bonding and connection. For workers cut off from traditional social networks, this chemical response partially replicates the benefits of human interaction that are otherwise absent. The high palatability also stimulates hedonic hotspots in the brain, generating dopamine spikes that provide direct reward and mood elevation. These aren't abstract psychological benefits, they're measurable effects that counter the chronic stress of Arctic industrial work. A worker experiencing dopamine reward and oxytocin bonding is more cognitively stable, more emotionally resilient, more capable of maintaining focus during demanding tasks. The food literally alters brain chemistry in ways that enhance performance. The operational logic becomes clear. In zero-tolerance environments, human error is the primary threat. Fatigued, stressed, demoralized workers make mistakes. They miss details, they cut corners, they fail to follow protocols. Any of these failures can trigger catastrophic consequences in industrial operations where equipment failure means immediate death. Quality food directly mitigates this risk. A well-fed worker with stable brain chemistry is more attentive, more careful, more reliable. The cost of flying in fresh king crab and maintaining industrial-grade culinary operations is substantial, but it's cheaper than the alternative. One serious accident, one equipment failure caused by human error, one safety protocol violation, one moment of inattention costs more in lives, liability, and operational shutdown than years of premium ingredient budgets. Workplace meal analysts note that quality food plays a pivotal role in nourishing the spirit, enhancing overall performance, and fostering positive work atmosphere. In the context of Arctic oil operations, this isn't corporate wellness language, it's risk management. The ribeye steak isn't a luxury, it's a calculated investment in the psychological stability that prevents the errors that kill. Steak nights function as ritualized anchors. These events aren't random, they're scheduled, anticipated routine. Workers know that on specific days, they'll get high-quality cuts and classic sides. The ritual breaks monotony, provides something to look forward to, creates structure in the otherwise undifferentiated stretch of the 21-day rotation. The psychological value of anticipation and routine reward compounds over the weeks of isolation. The industrial catering strategy reveals the hidden cost structure of extreme environment operations. The warm meal isn't peripheral to the work. It's central to maintaining the human system that performs the work. In environments that push human limits, sustaining human function requires precision engineering of every life support mechanism, and food is life support. The food system in Alaska's Arctic oil camps is infrastructure as critical as the drilling equipment itself. It delivers 4,100 calories daily to counter the energy tax of extreme cold. It operates 24/7 to synchronize with continuous operations that ignore traditional time. It maintains dual supply chains, daily air freight, and seasonal ice roads to guarantee delivery despite Alaska's fragile food security. It stockpiles 30-day reserves engineered for psychological endurance as much as caloric survival, and it leverages neuroscience, using comfort food to trigger the brain chemistry that stabilizes isolated workers and prevents the human errors that threaten zero-tolerance operations. The scale of investment reveals the actual priority structure. Flying in fresh seafood costs more than basic rations. Building million-gallon ice roads costs more than accepting supply gaps. Maintaining professional culinary staff costs more than utilitarian feeding. But in the Arctic, these costs are non-negotiable because the alternative, degraded human performance in high-risk operations, carries catastrophic price tags measured in lives and operational failure. The warm meal in the North Slope camp is the guaranteed fuel that prevents exhaustion. the chemical reward that stabilizes the mind, and the cultural anchor that connects workers to comfort in total isolation. It's not an extravagance, it's engineered life support. And in the world's most challenging industrial environment, life support is what keeps the operation running.